So on Wednesday, we talked about sum and difference of cubes and just what that really meant. And we learned these two formulas, or we were introduced to these two formulas. And again, you don't have to memorize these. They will be given to you. But it's important to know what they are. So you have the sum and the difference of cubes. Then that means that the sum part means if you have two perfect cubes, like something cubed like A and something cubed like B, and they're added together, then you can factor it into this form. All you have to know is A and B, and the same thing is true with the difference of cubes. If you have something cubed and they're subtracted, then you can use this formula for factorization that will help you out with those difference of cubes. So we're going to start with 8x cubed plus 27. So I know this is a sum of cubes because it's has a plus sign in the middle. So this is supposed to be a cubed plus b cubed. So I've got to figure out what times itself 3 times is going to give me 8x to the third. Well, that's going to be 2x. So that tells me that A is 2x. And b cubed means something to the third power gives you 27. And that part is 3, so that means that b is 3. I'm going to go ahead and highlight that red just so that we have a difference here. We can see that b is going to be 3. So our formula for the sum of cubes says that a plus b times a squared minus ab plus b squared will give us our factorization. So all we have to do is just plug in stuff. So every time we see an a, we're going to plug in 2x. And every time we see a b, we're going to plug in 3 and just see what that gives us. So we have a plus b. Well, that's easy enough. That's 2x and then plus 3 times. This next part here says a squared, and this is where a lot of people tend to mess up because they just think, oh cool, it's 2x squared and that's it. But I need you to remember it's the whole quantity 2x squared, which is really 4x squared because 2x times 2x is 4x squared. And that next part, that minus ab, means that we're going to subtract and then a times b. So we've got to multiply 2x times 3, which is 6x. And then plus b squared. Well, b squared would be 3 squared, so that would be 9. So your final answer to this factorization is 2x plus 3 times 4x squared minus 6x plus 9. That means that if you were to go and multiply and distribute all of this back out, you would actually end up with 8x cubed plus 27. So just starting with another kind of basic one here, we're going to do x cubed minus 125. And see what that gives us. So we can tell this is a perfect cube because x cubed is a perfect cube, obviously. So that means in this case, it's a difference of perfect cubes because there's a minus sign in the middle. So that's going to be a cubed minus b cubed, which a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And we just need to figure out what cubed is going to give us x, and then minus what cubed is going to give us 125. So that way we can know what a and b are. So x cubed is, well, obviously x to the third power. 125 is 5 to the third power. So a is x and b is 5. So I'm going to plug in everywhere that I see an a, I'm going to plug in x. And everywhere that I see a b, I'm going to plug in 5. So first of all, I have a minus b. Well, a minus b would be x minus 5. And then I have a squared. Well, that's x squared plus a times b would be 5x. Plus b squared, and 5 squared would be 25. So some of you are like, okay, I'm still just not quite sure where some of the things are coming from. So I'm actually going to go over here and I'm going to physically write in and substitute in these numbers for a and b to help us out here. So we kind of already know what's going to go where. We know we're going to have an a here, and that then we're going to do something here with A, and then we know that we're going to do B here, here, and here. I'm going to fill in all those signs and everything else now. So minus, there's a squared, a plus, and a squared. So A, we know, was x in this problem, so I'm just going to write that in where all of my red bubbles are. But it's important to remember that if you take out a letter and you plug in a number, you really should put that number in parentheses just so that you know what it is that you're doing. So I'm going to do the same thing everywhere there's a B. I'm going to put a 5, and I'm going to put that 5 in parentheses. So then I can actually just manipulate this a little bit and work it out to give us something prettier. So I have x minus 5 still, so that's going to stay x minus 5. Then it says x squared, which is just x squared, plus x times 5 is 5x, plus 5 squared, which is 25. So that is how we end up with the answer that we got for this problem. So as we look at our next problem, 250x to the fourth plus 128x. Well, remember when we're factoring, the very first thing we should always look for every single time without fail is we should look for a GCF. So we need to figure out if 250 and 128 have anything in common. Well, just using common sense, I know they're both even because they end in 0 and 8, so that means I know they're both divisible by 2. And they both have an x in there, so technically I can factor out a 2x. And if I factor out a 2x, then I am left with 125x to the third plus 64. Well, I don't necessarily, I know now that 125 and 64 don't have anything in common, but I do also know that 125 is a perfect cube, and I know that 64 is a perfect cube. So this is really a sum of cubes. So a cubed plus b cubed equals a plus b times a squared minus ab, plus b squared. So all I have to figure out is what's a and what's b. So I know that in order to figure that out, I have to write 125 as something cubed, and I have to write 64 as something cubed. So thinking about 125, 125 I know is 5, and then don't forget you have your x to the third, which means that it's really 5x, which makes sense because if you were to multiply 5x times 5x, you would get 125x to the third power. And then I'm going to do the same thing with 64. So 64 from our list yesterday was 4 to the third power. So that means a is 5x and b is 4. And all I have to do is go and plug them into my formulas. Again, every time I see an a, I am plugging in 5x. And every time I see a b, I am plugging in 4. So starting off, we have a plus b, that's easy, 5x plus 4. And then the next part says a squared, which means I need to take 5x and I need to square it. Keep in mind, when you square 5x, you are squaring the entire quantity, not just the 5, not just the x, so it's really 25x squared minus a times b would be 5x times 4, and 5x times 4 would be 20x. And the last part says b squared, which would be 4 squared, so that's going to give us plus 16. So my final answer to this problem would be 5x plus 4 times 25x squared minus 20x plus 16. You have to make sure that you are looking for your greatest common factors, because even if you don't find your greatest common factor, a lot of times they will actually factor, especially if it's a difference of cubes. But that doesn't help you in the long run because you still end up having to factor out something later on, and that makes things honestly a little bit more complicated for you.